Hello everyone and welcome. Today we're going to be looking at drawing Lewis structures. Okay, and this is extremely important for knowing how to draw going forward. Okay, so we're going to look at 5 or 6 different sections or different types of things to draw with an example or two of each. Okay, we'll start off pretty easy and then we'll get a little bit more complicated. So, let's first try some elements. Okay, and the title of this is Drawing Lewis Structures. Now, there isn't a formal lesson to this. Okay, however, if you have a sheet of paper or anything like that, I highly recommend you trying these out. Okay, so the first one, let's go ahead and let's draw lithium. Okay, now once again, we're doing Lewis, okay? We're not doing Bohr-Rutherford. So to draw Lewis diagrams, all we need to know is our symbol, which is lithium, and we need to know how many valence electrons we have. So we only have 1 for lithium here. Okay, and that's it. Okay, if you'd like to try the next one, you can. Okay, we'll do carbon. So if you'd like to pause the video at any point to try any of these examples, once again, I always recommend that. Okay, so for carbon, we have C and we'll have 4. 1, 2, 3, 4. Okay, so that's just how we would draw our elements. What about our ions? Okay, so first let's try lithium ion. Okay, so the first thing you need to remember from lithium is that it has 1 valence electron. Now, what's going to happen to that 1 valence electron? Well, it's going to leave. So we would get lithium. Okay, now as you notice, there's no valence electrons around it. Okay, they're all gone. We put our square brackets and we put the charge 1 plus. Number first, charge second. Okay, what about sodium? We could try sodium as well. Okay, so sodium, once again, is Na. Sodium also has only 1 electron, so it's going to lose that 1 electron. So if you remember your Bohr-Rutherford diagrams, we always leave that valence shell there because the valence shell is empty. And we're doing that by doing this with our Lewis structure because the valence shell is empty and we have 1 plus. Okay, and let's try one more. Nitrogen. What would the ion be for nitrogen? Okay, so for nitrogen, it has 5 electrons all the way around. So it's going to pick up 3. So 1, 2, 3, 4, 5. Now it's going to pick up 3. So you could put 3 more dots, which is fine. I like to put little X's to just so I know that these were ones that got picked up. Okay, now it doesn't matter if you want to put your X's or if you just put the dots. Okay, they're both fine. You'll both get correct marks as long as you have your square brackets and you tell me it's a 3 negative charge. Okay, so you can have it with the X's or you can have dots. All right. Next, let's try some ionic compounds. Okay, I'll move this up a bit. All right. So we're going to try 2 of them here. So the first one, let's try magnesium chloride. Okay, now the first thing that you're going to need to do is you're going to need to come up with what the formula of this compound is. Okay, so in order to do this, we need to come up with this formula. So magnesium is a 2 plus, chlorine is a 1 negative. Once we do this crisscross, we get MgCl2. So that's what our compound here would be as a formula anyways. So what that means is we're going to have 1 magnesium and we're going to have 1 or 2 chlorine, sorry. Now, these are all ions. So what we're going to do is we're going to draw them as ions. So we first have our magnesium. Now magnesium is 2+. That means it lost 2 electrons, so there's not going to be anything around it. So we have 2+. And then we have chlorine. So chlorine are 1 negative. So I'm going to draw 1, 2, 3, 4, 5, 6, 7, and I'm going to put my 1 electron there because it gained 1. Now, one common mistake that a lot of students will do is that they'll say, oh, wait, well, it picked up 2 electrons, so this must be 2 negative. Well, no, it's not. It's actually only 1 negative because chlorine only picks up 1. So what we need to do is we need to draw a second chlorine. And once again, this is Mg, 1 magnesium, 2 chlorines, all ions coming together. Now, a more simple way of drawing this is like this. We'll have our magnesium, and I'll have my chlorine, but instead of having to draw a second chlorine, I could put a 2 in the front. And what that says is I have 1 magnesium, 2 chlorines, magnesium chloride there. All right, let's try another one. Let's just use another one here. All right, so let's try lithium oxide. So once again, you need to understand that lithium oxide, 1 metal, non-metal, so we have an ionic compound. So lithium is 1+, oxygen is 2 negative, so when we do our crisscross, we're going to get Li2O. So I'm going to need 2 lithiums, 1 oxygen. So my lithium, well, 1+ means it lost all its electrons, and I have 2 of them, so I'm going to put a 2 in the front. And for oxygen, I'm going to have 1, 2, 3, 4, 5, 6, and I'm picking up 2, so I have 1, 2, and I put 2 negative. So that's lithium oxide here. Okay, so those are my ionic compounds. Once again, ionic compound is 1 metal and 1 non-metal to form that. Now, what about covalent compounds? Okay, we draw these a little bit differently. Okay, so let's go ahead and let's try and draw CH4. Now, before starting, you should notice the difference. These have 2 non-metals. This has a metal and a non-metal. The way we draw ionic is different than how we draw covalent. Okay, big difference. Okay, ionic compound, electrons get transferred. When they get transferred, we put the square brackets to denote that, and so forth. Okay, so for our covalent compounds, we're going to have, we're going to have carbon in the middle. Now, how do I know carbon's in the middle? Whichever one has the less amount. Okay, so there's only 1 carbon here, 4 hydrogens, so carbon's in the middle. Now, carbon has 1, 2, 3, 4, just like we did with our Lewis. Now, 4 hydrogens, there's 4 bonding spots, so each hydrogen is going to go around. And what you're going to do, okay, is we are going to bond each one. So this carbon is going with this hydrogen, this one's going over here, and this one is going over there. And we have this last one. It's not going to look too pretty, but you get the idea. So there's going to be a bond between each carbon to each hydrogen. So when we finish drawing this, we're going to get carbon to a bond to each hydrogen all the way around. All right, let's draw another one here. Very common one, H2O. All right, so as you can see, we have 2 hydrogens, we only have 1 oxygen. So oxygen is going to be my middle. So I'm going to have 1, 2, 3, 4, 5, 6. Okay, now if you go in order, you should be able to get them right every single time. Now we're going to have 2 hydrogens. So there's 1 spot over here, and there's 1 spot over here. So what's going to happen is these 2 are going to come together here, and these 2 are going to come together there. And what we have, and you want to draw it in the same orientation. So we're going to have oxygen, 1 hydrogen at the bottom, 1 hydrogen at the side, and then you need to make sure you put your electrons, 2 at the top, 2 at the bottom. And that's what we get there. Now, these are all single bonds. Okay. What we're going to try now, we're going to try 2 of them that have double bonds. Okay? Or multiple bonds anyways. Okay, so we're going to try 2. The first one, let's try the diatomic molecule N2. Okay, so in order to draw this, 2 nitrogens means that we need 1 nitrogen. We're going to need a second nitrogen. And once again, because these are Lewis, we need to draw them as Lewis structures. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, looking at these here, what you should notice is that we have 1 bond here. We're going to have a second bond between them. And we're also going to have a third bond between them. Okay, once again, this is not the nicest bond. But the reason we do 2 drawings is 1, to see where all the bonds are going, and the second one, to see what we have. So if we have nitrogen here, we're going to have nitrogen to nitrogen. And there's 3 bonds, 3 things being shared. So 1, 2, 3. And each of these bonds, you should remember, have 2 electrons in each of them. Okay. Now, the last thing you need to make sure you put are your 2 electrons for nitrogen. And that's what we have there. Now, a question that I get a lot. What if I drew it like this? Okay, triple bond. What if I had 1 at the top, or let's say I had them at the bottom? Would that be right? Well, it would be, because you need to remember electrons need to stay together. So it doesn't matter if you put the electrons on the sides or the tops or the bottoms, as long as they are together. What would be incorrect is if you drew it like this. See how I split up the 2 electrons? That would be incorrect. They need to be together, like that there. Okay, so that would be incorrect. All of these would be fine. All right, let's try another one. Let's try CO2, carbon dioxide. So in order to draw this, we need to have whichever one has less amount, that's our middle. So carbon is our less amount. So we have carbon, 1, 2, 3, 4. And we're going to have 2 oxygens. Now, where are these oxygens going to go? Well, they're going to repel each other. So they're going to want to be on opposite sides. So I'm going to put 1 oxygen here. 1, 2, 3, 4, 5, 6. And 1 on the other side. 1, 2, 3, 4, 5, 6. Now, carbon wants to bond 4 times. Each of these wants to bond 2. So 2 times 2 is 4. So what we could do is we could have 1 bond here, 1 bond there. So 2 going to one side, and then 2 going to the other side. So 1's here, and then once again, this one's not going to look too nice, but that there. So we have 2 bonds going one side, 2 bonds going to the other. So we would have carbon with a double bond to 1 oxygen and another double bond to the other oxygen. Okay. Now, we need to make sure we have those electrons for oxygen. So it doesn't matter where you put it. 1, 2, 1, 2, or 1, 2, 1, 2. It doesn't matter as long as they are together. And that's what we have here. All right. So those are ones that you should have seen in the past. Okay. Pretty much grade 10 and grade 9 science. Okay, now the ones that we're going to take a little bit more time now with are our polyatomic ions. And these ones are a bit trickier. Okay, All right, so let's start off with PO3, 3 negative. Now this here is called phosphite. Okay, phosphate is PO4, phosphite is PO3, one less oxygen. So with that being said, not every single time am I going to give you the compound here. I'm going to most likely give you the name. Okay, once again, it is great. It is a university level class. So with that being said, what we're going to do, which one do we have less of? We have less phosphorus. So once again, pretend that charge isn't there. How would we draw this? Well, we would have one phosphorus in the middle. 1, 2, 3, 4, 5. And we have 3 oxygens. Now, I see 3 openings, so I'm going to put 1 here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. All right, so that's going to be my shape. Now, the first thing you need to make sure is that every single one of the outer elements is connected to the inner one. So for the first one, I'm going to have 1 bond here. I'm going to have 1 bond there. And I'm going to have a 3rd bond here. Now, one thing you need to remember is that we cannot break the octet rule. Okay, so a lot of people will try and fit like a double bond somewhere, okay, but that's not good because the reason why is if you take a look, let's look at phosphorus in the middle. It has 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus is happy, so we can't add any more electrons there. But let's look at our oxygens. It has 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So all of the oxygens have 7. So what can we do to make them happy? Well, let's look at right here. We have charges, 3 negative. 3 negative means we need to add 3 electrons. So where do you think they're going to go? Well, 1 electron is going to go right here to make that oxygen happy. 1's going to go over here, and the last one is going to go over there. So when we draw PO3, we're going to have 1 phosphorus to 1 oxygen, to a 2nd oxygen, to a 3rd oxygen. Our phosphorus needs 2 electrons at the top, and each oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And if you count every single element, so once again, if you look at the phosphorus, if I cover my oxygens, I have 1, 2, 3, 4, 5, 6, 7, 8. Remember, those count as 2. For my oxygens, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8. So everything is happy. Now, because it is an ion, I need to make sure I have my square brackets. And I need to put my charge, which is 3 negative. So that is phosphite. All right, let's try another one. Okay, this one is called hydronium. Okay, now this one you don't have. So that's why I'll give you this compound formula. But we have H3O1+. So once again, in order to do this, which one's in the middle? Well, I only have 1 oxygen. So I'm going to start off by drawing my oxygen. 1, 2, 3, 4, 5, 6. Now this one is a little bit tricky. And the reason why this one's tricky is because we have 3 hydrogens. So I have 2 spots. So I'm going to put 1 hydrogen here because I know it'll bond. I have 1 hydrogen here because I know I'll bond. But where does my 3rd one go? Well, unfortunately, it's going to have to connect to the oxygen. So I'm going to have to actually break up one of these 2 bonds. Now, I'm going to pick this one because for me, I like drawing my compounds with everything at the bottom. You don't have to. You could put it at the top. It would give you the same right answer, just a different orientation. But anyways, I'm going to put my hydrogen on this side. So I'm going to have my first bond, my second bond. Can you guys see that? Yep. Okay, and then my 3rd bond. Well, unfortunately, I'm going to have to break these up. These 2 don't want to be broken up, but this hydrogen says I need to get in here. So I'm going to break up one of these bonds. Now, all of these hydrogens are happy. It has 1, 2, 1, 2, 1, 2. However, let's look at my oxygen. I have 1, 2 at the top, 3, 4, 5, 6, 7, 8, 9. Can we have 9? No, we can only have 8. So what can we do? Well, once again, 1 plus means we lose an electron. So which electron do you think we're going to lose? Well, most likely we're going to lose this one here. So this one's going to go, okay? It'll kick it out. When that happens, we will have this here. We'll have oxygen in the middle, a bond to one hydrogen, a bond to a second hydrogen, a bond to a third hydrogen, and then I need my 2 electrons at the top. Square brackets, and I get 1 plus. All right. Now we're going to do 2 more. Okay, so these 2 that we're going to try. Okay, we're going to have to do a little bit of rearranging for these 2. These are our more complicated ones. Okay, it's not going to get much harder than these though. Okay, so let's try our sulfite, SO3, 2 negative. Okay, that's the first one we're going to try. So, if you'd like to give this a shot, once again, I highly recommend it. Okay, just so that you get confused, that's okay, because then you'll learn. Okay, so if you'd like to pause the video, you can. So, I have 1 sulfur, so that's my middle. So, I'll have 1, 2, 3, 4, 5, 6 for sulfur, because it's in the same family as oxygen. Okay, actually, I don't like that. I'm going to redraw it. So I have 1, 2, 3, 4, 5, 6, and I have 3 oxygens. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then I have the same issue as last time. Okay, so I have to break up a bond. 1, 2, 3, 4, 5, 6. Now, step number 1. Everything needs to be connected to the central atom. So my first oxygen electron is going to go here. My second one's going to go here. And then just like last time, I'm going to have to break this up. Okay. Now, the problem is, once again, take a look. Okay. Oxygens, they all need 1. Sulfur has 1 too many. Okay, if we count that around. Okay, so once again, oxygen has 1, 2, 3, 4, 5, 6, 7. So we need 1. So sulfite, has a 2 negative charge. So that means I can add 2 electrons. Now I'm going to add the first one over here. I'm going to add the second one over there. Now this oxygen's happy and this oxygen's happy. But these 2 aren't. So what can I do? Now, a lot of people will say this. Well, why don't you make this a double bond? Okay. So if I tried to connect this one and this one, I would get something like this. And I'll just redraw it. Okay, you would get something like this. You get sulfur, double bond here, single bond, and then 2 electrons at the top. Okay, if I made that into a double bond. What's the problem with that? Well, the problem is, let's look at sulfur here. Sulfur is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's going to have 10 electrons. That is not correct because we have to stay within 8. So what's going to happen is that this electron is going to reconfigure itself. It's going to move. It's going to become more stable, and it's going to actually move right over here. It's just going to move spots. Electrons can move. They're always moving. They're free moving. So what's going to happen is that the electron's just going to move over so that it'll become more stable. So we would get this. We get sulfur, 1 bond to oxygen, 1 bond, third bond, 2 electrons up at the top for sulfur. This oxygen is going to have 6. 1, 2, 3, 4, 5, 6. This one's going to have 6 as well. This one has 1, 2, 3, 4. 1, 2, 3, 4. It had the fifth one, and then it took this one and it moved there to make 6. And now everything is happy, and we didn't break the octet rule. So we put our square brackets, and we put 2 negative. All right, last one. Okay, same idea as this one here. Okay, we have chlorate. Once again, I'm not always going to give you the compound formula. I'll probably give you the name, but you should be able to come up with what chlorate is. So anyways, try this one out and see if you can get it. All right, so for chlorate, chlorine and oxygen. So we only have one chlorine, so I'm going to have Cl, and it has 1, 2, 3, 4, 5, 6, 7. So for this one here, I need to fit 3 oxygens. So right away, I need to break up 2 of those bonds. I already know I have to break them up. Okay, so I have my first oxygen here, 1, 2, 3, 4, 5, 6. Second one here, 1, 2, 3, 4, 5, 6. And my third one here, 1, 2, 3, 4, 5, 6. Okay, my first step, make a bond to each of them. 1. Okay, this one I'm going to have to break up. 2. And this one here, I'm also have to break up. And 3. So everything's connected. Now, I have 1 electron that I need to add in. So I'm going to add it over here because there's no way of rearranging this side of my compound. However, what about this side? What can I do with these electrons? Well, just like I did on the last one. This one can move over here. And this one can move over there. Now, my simplified version is going to look like this. I'm going to have 1 chlorine. I'll have 1 oxygen, 1 oxygen, 1 oxygen. Okay, those are my 3 bonds. I have my 2 electrons at the top for chlorine. Okay, that gives me 8 electrons for chlorine. For oxygen, I'm going to have 1, 2, 3, 4, 5, 6. This one here, I have 1, 2, 3, 4, 5, and then I switched it around. 1, 2, 3, 4, 5, and then that's that other last electron. And the same thing here, 1, 2, 3, 4, 5, 6. And then I put my square brackets, and I put my 1 negative charge. And that's how I draw polyatomic ions. Okay, now one thing that a lot of grade 11s make the mistake of is they add too many bonds. They break the octet rule. So make sure you don't do that, and you'll be fine. Okay? So, thank you for watching, and have a great day.